In Lesson 9-7, we're going to finish our solving of quadratic systems by comparing them and solving them with linear systems. This means we'll have a line and a quadratic or parabola, and they'll intersect. We want to find those x values where they cross. We'll use some methods that we learned when solving linear equations to help us. So if we look at this example, they ask, when does 5 minus x squared equal x plus 3? When we solve these, Desmos can be super helpful. So for example, if we were to graph 5 minus x squared and x plus 3, the simplest way to describe how they have solutions is to click or find where they meet. Now notice that they cross at these two locations. They are interested in, for their example, the x values in which they meet. And we know that because there's x's. This is saying what x value would work to plug into both sides of the equation and they will be equal. So we would say x equals -2 and x equals 1 from the graphs here. So example 2 in the triads had us just graphing, and that's always a good way to check where the solutions are when they meet. But now if they want the solutions to the system here, notice how it looks a little different. One way to think of this could be writing x squared minus 6x plus 8 equals 2x minus 4, and we would solve what x value would make them equal or where do they cross. But another way we can do this is by using elimination. And this will take us back to when we had two lines and we wanted to find where they crossed. We're going to begin by subtracting. If we take the first quadratic or parabola and subtract the line, y take away y would be 0. X squared, notice how there's no other x squared. Be careful that just because they're stacked on top of each other doesn't mean we can actually operate those two values. A -6x take away a 2x makes -8x. And finally, 8 take away -4. When you subtract a negative, you actually add, so we get 12. Now this turns into a problem like we've been solving all throughout this chapter. When does this parabola equal 0? One way we could do this is by factoring. We could graph it, which we'll do that to check. But if I factor, I usually have my equation here. I could do my box, and I know I want x squared and 12, and I want to add to -8, but add to 12x squared. And I know that is a 6 and a 2. But both of them have to be negative in order to add to -8. So by doing this, I get x minus 2 and x minus 6. So we're able to use factoring, like we learned in this chapter, to solve this, and we want to know when it equals 0. Remember to keep going and tell me that 2 would be the value that we would plug into this first parenthesis to make it become 0, and 6 would be the other one. So this is one way we can solve. We can take our quadratic and subtract our linear and do factoring. To check if this answer is right, we could go ahead and graph these two equations. We have a couple options. We could graph this quadratic and find where it hits the x-axis, or we can graph both of these equations and see where they meet. Just to be sure, I graphed both of the original equations, and I see that they cross at x is 2 and x is 6, which does match our solutions here. And again, if you're trying to solve these with elimination, you just go ahead and subtract. If we set up triad 3a, and I subtract these, I have y take away y will be 0. Notice how I don't have any x squareds in the first one. So I have 0x squared take away 1 will leave me with a -x squared. I have a -x, but no x is down here. So I'm left with -x, and 4 minus -2 would be 6. The trickiest part about these is sometimes your subtraction can go wrong, so then it makes it trickier here to know if you're solving the right quadratic. One step you can do when your x squared is negative and you have it equal to 0, you could divide everything by a negative. Sometimes this can help you with factoring. So if I had 0 equals x squared plus x minus 6, this makes it easier for me to factor because I know that x times x would be x squared in my box. And 3 times 2 would be 6. But if I make my 2 negative, I'll have 3x take away 2x, making 1, and negative 2 times 3, making negative 6. So you may need to do your factoring with the box over here if you want to, but that would be our result. So my final answer would be x equals 2 and x equals negative 3. It should be noted that we do have the x value in which they cross, but to find the y value, which I probably should have done on the last example, you can plug it back into either of these equations, because we knew from our graph on the last one that 2, 0, and 6, 8 were our solutions. If I went back to that side here, I know that 2 is my x value. I can plug 2. I'm going to use the simpler equation, the line one here. I'm going to put y equals 2 and substitute in my 2 minus 4. And 4 minus 4 is 0. That point of 2, 0 is my first solution. So we want to give the full coordinate, not just the x value this time. You might say, why not just the x value? Well, our equation, or both equations up here, have x and y. So now I'll do the same thing here. I'm going to put y equals 2 times this x value of 6 minus 4, and 12 minus 4 is 8. So my other solution would be 6, 8. Again, once you see, if you're solving a solution of two equations, you want the x and the y value when you solve them, as compared to when they asked for, when these two equations are equal, you just need the x value.